They built ice in the desert. Not near a glacier. Not with a machine. Not with electricity, compressors, or anything you would call refrigeration. In parts of Iran, people created a system that could make ice during winter nights, hide it underground, and keep enough of it alive through the summer heat. In a climate where summer temperatures could push far above comfort, that was not luxury. That was control over food, water, medicine, trade, and status. And the genius of it is this. They did not beat the heat head-on. They found moments when the desert itself turned against the sun. That structure is called a Yakhchal, literally an ice pit. But calling it an ice house is too weak. A Yakhchal was really a seasonal thermal machine, part architecture, part physics, part logistics. And once you see how it worked, the story stops being ancient people were clever and becomes much more interesting. Because this was not about cold. It was about timing. The obvious problem was summer. Central Iran could be brutally hot. But the hidden advantage was winter night. In dry desert air, with clear skies and low humidity, heat does not always stay where you think it should. A shallow pool of water can lose heat upward to the night sky faster than the surrounding air seems to justify. One classic engineering study found that under clear winter conditions, ice could form even when the air temperature was as high as 4 degrees Celsius, because the effective sky temperature was far lower. That is the first twist in the story. The desert was not simply hot. It was thermally extreme, and Persian builders learned to use the cold half of that equation. A typical Yakhchal complex was not just one dome in the sand. It often included a shallow ice-making pond, a tall shade wall, channels bringing water from a cannet, and the storage chamber itself. At night, water was spread into shallow basins. During the day, those basins were protected from low winter sun by long walls that reduced heat gain. Then night came, the sky cleared, humidity stayed low, and the water started bleeding heat upward. Radiation did the heavy lifting. Evaporation helped. By morning, ice had formed. Workers harvested it and moved it into storage. Then they repeated the cycle again and again. Here is the trick. The system did not need the whole winter to stay below freezing all day. It only needed enough good nights, and a way to not waste them. That is why the architecture matters so much. The dome you see in photos is only the visible part of a much smarter thermal strategy. The storage chamber went deep underground, where temperatures were naturally more stable. The walls were massive mud brick construction, thick at the base, thinning toward the top. In Maybad, one studied example is around 15 meters tall, with a pit about 5 meters deep and wall thickness estimated at roughly 2 meters at the base. Some analyses suggest the dome may even have been insulated further with thatch in summer. So the second twist is this. The dome was not mainly there to look impressive. It was there to slow time. Every hot day outside was trying to destroy the winter stored inside. Thick mass delayed that attack. Underground depth buffered it. Small openings limited heat gain. And once a large block of ice had been accumulated, that mass of cold became its own defense. Melt the outside too fast, and you still have a protected interior. In modern modeling work, the ancient construction logic performed with heat transmission low enough to look surprisingly competitive on paper with heavily insulated modern assemblies. Not because the materials were modern, but because the system was optimized around climate and season. That is why Yakhchals are so watchable as engineering stories. They are not primitive refrigerators. They are environmental algorithms built out of mud. And like all real engineering, they came with constraints. First, not every Yakhchal was the same. Some were true ice-making systems. Others mainly stored winter ice or compressed snow brought from elsewhere. Iranica is explicit about this, and that matters, because the lazy version of this story overclaims the technology. The strongest version is more honest. Persian builders created a family of ice storage systems, and in the right climates some of them could also manufacture ice on site using night cooling. Second, this only worked because the climate cooperated. Clear skies mattered. Low humidity mattered. Cold nights mattered. The system was elegant, but it was not universal. Move it into the wrong atmosphere, and the trick collapses. This is the trade-off hidden inside the romance of ancient engineering. The design was brilliant precisely because it was local. It exploited one environment instead of trying to dominate every environment. Third, there was labor. Someone had to manage water, harvest ice before sunrise, warming accelerated melt, move it, stack it, protect it, and ration it. Max Fordham's review notes that these systems were reportedly run either as community operations or as businesses selling ice. So this was not just passive architecture sitting there doing magic. It was infrastructure with management, routines, and probably rules. And that is where the story gets bigger than one dome. Because once a society can store winter and spend it in summer, heat becomes a little less absolute. Food lasts longer. Water can be cooled. Desserts and drinks become possible in places that should have erased them. A harsh climate does not disappear, but it stops fully dictating daily life. That is what infrastructure does at its best. It does not change nature. It changes your bargaining position with nature. There is also a reason this story feels modern. Today, cooling is usually framed as a machine problem. Add power. Add compressors. Add more demand to the grid. But Yakhchal's came from a different engineering worldview. Instead of asking, "How do we generate more cold right now?" they asked, "When does the environment offer us cold for free, and how do we keep it?" That is seasonal energy storage, centuries before anyone used the phrase. In one modeled Maybot example, a roughly 400 square meter ice pond was estimated to produce around 50 cubic meters of ice in a winter season, about 3 million modern ice cubes. Even the analysts note that figure may be conservative, and that colder historical winters or imported supplemental ice could explain how some stores were filled more deeply. But even that conservative number tells you what this really was, not a novelty, but a serious urban system. So no, the Yakhchal was not a miracle. It was harder than that. It was disciplined. It was geometric. It was seasonal. And it worked because the builders understood something many modern systems forget. Sometimes the smartest machine is a building that waits. The desert did not become cold. The Persians just learned when the desert was willing to surrender it.
And that leaves the real engineering question. Was this ancient refrigeration more elegant than modern cooling? Or was it only elegant because an entire society was willing to build life around the climate instead of demanding instant control over it?